All right, so we are going to do related rates. What I think is so cool about related rates, because I know all of you are stressing about this like already, is that, yeah, we're gonna like work out these problems on a piece of paper by hand, but your brain does related rates automatically in real life without you even being aware of it. For example, this is the example I always bring up because I just think it's silly. If you're in the grocery store and you're with your cart and someone else is with their cart and you're coming towards each other, your brain will automatically figure out how fast you're going versus how fast they're going and regulate your speed so that you don't crash into each other. That's your rate related to their rate. Do you get what I'm saying? And like, you don't have to stop what you're doing and work out a calculus problem to figure it out. Your brain just does it, which I think is so cool. Like, our brains just do calculus without us even like being aware of it. So yeah, we're gonna do these problems, but just remember, in essence, it's just how one thing is related to something else. So just remember that everything's moving. And that's why I have the little projector up here so that you can see the motion, because obviously on a piece of paper, there's not like moving pictures. So I have the little videos that we're gonna watch. So here's, directions. You're gonna draw a picture if necessary. Sometimes it's just about like a circle and you don't need to draw a circle, but most of the time you'll have to draw a picture. List out the given information and the missing value. I call that the question mark value. And I always say, write yourself a note whether it should be positive or negative. If a distance is increasing, you'll have a positive rate. If something is lessening, you'll have a negative rate. Write a relationship between the variables. You need an equation that shows the relationship between the variables. Oftentimes it will be either trig, sine, cosine, tangent, or Pythagorean theorem, or if you're talking about an area or volume of something, it'll be the area or volume formula, and those are sometimes given and sometimes not. If it's a simple one, like area of a circle, you would have to know that. Do you guys know area of a circle? Okay, like if it's something small, like now if it's volume of a cone, that's going to be given to you. We're going to do that one. I know you guys are already thinking about it. All right, and then here, take the derivative. You need to take the derivative before you plug anything in. Is that clear? Because the derivative gives you the rate, okay? And every variable is with respect to time. They're all going to be whatever dt. So like if it's volume, that's dv dt. Area is dA dt. You'll have dx dt, dy dt. They're all with respect to time. Time is your independent variable. Then you can plug in. So do the derivative, then plug stuff in. If you're missing something, you can go back and do a side problem and find it. And then put units. Rates should be something per something else. All right, so if you have a rate, it should be something per something else. Let me share my screen and we'll do the first one. Gosh, there's so much stuff on here. All right, a 6-meter ladder. Now everything's moving, but the ladder is not the incredible growing or shrinking ladder. Okay, I know there are extendable ladders, but the ladder length is not changing. That is 6 meters, leaning against the wall. The bottom of it is sliding out at a rate of 0.5 meter per second. We're going to list all this out. I just want to show it to you first. How fast is the top of the ladder sliding down when it reaches? And then they do this where there are like all these different questions. We're only going to do the first one, okay? Like I see no point in doing this problem 3 times. How fast is the top of the ladder sliding down when it reaches 5 meters? So here's what it looks like. The ladder is falling. And then just like in real life, it gets back up again. Okay, but that's what's happening, is it's motion, it's moving. Have you guys all got a visual of that? Because I can't have what I'm going to write on and this up at the same time. I'm going to have to take it down, but you all have a visual of that? Okay. So our picture is going to be a right triangle. And anything that is constant, you can label. The ladder was a constant 6 meters. That isn't changing. But anything that's changing, you have to label with a variable. So this distance was changing. I'm going to call it x, sliding this way. You can put arrows on if that helps you too, to like visualize it. And then this distance was changing. I'm going to call that y. The top of the ladder was sliding down. So if there's a quantity that's not changing, you can label it with a number, a value. If it's moving, it has to be a variable. Does that make sense? Constant versus variable. Okay, thank you for heads nodding. All right, so it said that the bottom of it was being pulled out at 0.5 meter per second. We're going to label that dx dt, And it would be positive half a meter per second because this distance of x is lengthening, it's growing, so it's a positive rate. Does that make sense? Getting bigger. Our question mark was how fast is the top of the ladder sliding down? So our question mark is dy dt. That's what we're looking for. Should it be positive or should it be negative? Good. Negative, because it's sliding down, this distance y is shortening. This is getting smaller and smaller. I just always write myself a note. So like if we do this problem and get a positive answer, we can be like, oh, we had a whoops somewhere and fix it. Now everything's moving, but you have to pause at a certain moment. You can only talk about one moment at a time. And it said when the top of the ladder is at 5 meters. So when y is 5 meters, it's like we're gonna pause at that moment. Everything's moving, but like we're gonna hit pause at that moment. Are you all still with me? It doesn't seem like anyone's freaked out yet. Okay, now you need a relationship between the variables. It's gonna be Pythagorean theorem. So it will be x squared plus y squared equals 6 squared, which would be 36. You can just write 6 squared. And then you do the derivative. It's the most important step. It's actually the only step that is calculus. The rest of it's not calculus. The rest of it's just listing out information and plugging stuff in. It's the only step that's calculus. So it's like the most important step. So our derivative is going to be 2x dx dt plus, and then what would this one be? dy dt, good. And then derivative of 36 is 0. What that's representing is the rate of change of the ladder is 0 because the ladder is not changing. So again, every single variable is with respect to time. All right, now we're going to plug stuff in. What was x? I don't have that. We'll come back to that. What was dx dt? 1/2 plus 2 times y. What was y? 5. And then what was dy dt? That's what we're looking for. So you're just going to leave that in there. That's our unknown. That's what we're trying to find. Now, if you're missing something, you go back to the original relationship and plug into it. So we're going to go back to this original Pythagorean theorem, plug in what we have and look for what we don't have. We have that y is 5. I just do this off to the side. It's like a side problem. All right, it would be x squared plus 25 equals 36. We're going to do these without a calculator just to keep things simple. So don't simplify anything. Just like leave them all alone. Subtract that over, you would get 11. And so I'm just going to leave it as square root of 11. And so that's what's going to go right here. So if you're missing something, go back to the original relationship, plug in what you have, look for what you don't have. All right, the 2 and the 1/2 here are going to cancel. All we have to do is get dy dt by itself. So what would we do to get dy dt by itself? Yeah, so we're going to subtract this over. It would be negative square root of 11. And then we would have to divide by 10. 5 times 2 is 10. So negative square root of 11 over 10, which is a great answer. Don't discriminate. Oh, did it come out to the sign we thought it was going to be, positive or negative? Yeah, we wanted it to be negative. Units, it's a rate, dy dt. So it's got to be something per something else. Never make up units. They're going to be written in the problem. What will our units be? Oh, we've got your meters for this one. Meters per second. All right, let's try another one. That one seems like it went okay. Yeah, pretty much. Oh, I like this one. This one's about the boat. Look at the cute little boat. All right, a winch, which is this thing, the reel, at an altitude of 20 feet. It's not the incredible growing dock. That's at 20 feet. It's not changing, okay? Is reeling in a boat at 2 feet per second. How fast is the boat moving when the rope is 45 feet out? Again, they give all these other choices, but we're just going to do the first one. All right, watch. Here's what's going on. It's moving. And then just like in real life, it'll get pushed back out into the ocean again. I feel like it goes around the whole earth or something. Okay. We're going to draw a triangle, right triangle specifically. Anything that is not changing, you can label with a value. So what was not changing? Yeah, the vertical height of the duck, it was 20 feet. Oh, wait, was it meters? It was, oh, okay. I try to memorize the problem because I don't want to have to keep switching the screens back and forth. And I was like, I thought it was feet. All right. They called this R for rope, so I'm going to go with that. You can call it whatever letter of the alphabet you want. I really don't care. And then they called this X. And the boat is being pulled this way. So the rope is being pulled in at 2 feet per second. So how will I label that rate? It's the rope though, so there we go, dr dt. Now it said 2 feet per second, but the rope is being reeled in, so we're actually going to write it as perfect, -2 feet per second, because the amount of rope that's out there is being shortened. Our question mark, it said, how fast is the boat moving? So this is the boat. I'm not even going to, well, here, I'll try to draw a boat. There you go. The boat is moving this way, so that would, how would we label that race? dx dt is our question mark. Should it be positive or negative? Negative, good. Now you have to pause. Everything's moving, so you have to pause at a certain moment. It said when there are 45 feet of rope out. So that's when R is 45. So now we make a relationship between the variables. It's going to be Pythagorean theorem. So here, set it up for me. What's it going to be this time? Yeah, and you can write 20 squared. I just went ahead and wrote 400. It doesn't make a difference though. All right, and then the derivative. So what's our derivative going to be? Good, 2x dx dt. 400 is a constant, so that's nothing. Equals, good, 2r dr dt. And you can go ahead and cancel the 2's. Since you have a 2 on both sides of the equal sign, you can go ahead and cancel that out. That's the only step that's calculus. The rest of this is more just staying organized than anything else, listing out the information. So what is x? We don't have that. We'll come back to it. What is dx dt? That's what we're looking for, so you can just leave that in there. What's r? 45. And dr dt is -2. If you're missing something, you go back to what? The original relationship right here, the first step, plug in what you have. We have that r is 45. So this side problem here, x squared plus 400 equals 45 squared. Let me go ahead and say, I don't know what 45 squared is off the top of my head. I let you all down, didn't I? I'm really sorry. I don't know what 45 squared is. 2025. All right, subtract over the 400, you get 1625, which feels like it should be a perfect square because 16 and 25, but it isn't. So we're just going to leave it as square root of 1625. I know, I feel like that is a letdown a little bit, but it's not. So that goes right here. And then all you would have to do is divide that over and put some units at the end. 45 times -2 would be -90. I didn't do that. I just left it alone. It doesn't matter. But what would the units be? Feet per second. All right, so I'm going to share my screen again so we can look at the next problem. Oh, you know what? Hold on one second.